are going to climb Mount St Helens. But more than that, we're going to look at the geology along the way. We didn't conduct any of the research. We're merely looking at the field research of amazing geologists who have studied this in the past. So yeah, let's get started. All right, this is Climber's Bivouac. This is the starting line for all summit attempts on Mount St Helens. It's nestled at the base of the south side of Mount St Helens, which is not the side that erupted. If you notice, we're in an old growth forest. That's because this forest survived the eruption on May 18th, 1980. And if you look down, you see a gray layer. So the soil here has a distinct gray layer. That's ash and tephra and pumice and all that fun stuff from the eruption right beneath our feet. And then below that, there's lava flows from the Pine and Castle Creek lava flow eruptions. So before we even start our summit attempt, we're standing on old and new volcanic history. Okay, this is Monitor Ridge. This is above tree line on the main route to the summit of Mount St Helens. This is the route typically taken in the summer. If you look over there, you see the worm flows. So that's the worm flow lava flows. Geologists named it that because when you look at it from above, it's like sinuous lava flows that go down the mountain and it looks like a worm coming down the mountain. But we're on Monitor Ridge. And if you look behind me, there's a million boulders, well, probably a million, but there's a bunch of boulders on this route. And we're boulder hopping our way to the summit. The reason being is these are andesite and dacite lava flows. So they're not the runny, smooth, flowy lava that you see from Hawaii volcanoes. It's actually thick, toothpaste-like lava that actually builds up the volcano as it comes down. But it comes down slowly and it cracks and cools to form these big jagged chunks, which cool into boulders, which is what we're hopping over on our way to the summit. So let's go. Okay, I am at 6,840 feet up Mount St. Helens, and this is a geological monitoring station. So the United States Geological Survey, the Cascade Volcano Observatory, and the Pacific Northwest Seismic Network have these monitors up and down the volcano. And these are the eyes and ears of the volcano for us. So this measures ground deformation. So if the ground swells at all down to the millimeter, it'll measure it. It does gas emissions, magma movement, and seismic activity, and it even does atmospheric stuff. So it's technology like this from smart geologists that give us advance warning if she decides to wake up at any moment. Right now we're on the part of the hike where it's just loose scree for the rest of the way. And this is deposited from the 1980 eruption. So basically it's just ash, tephra, pumice, stuff like that, but it's loose rock. It is one step forward, half a step back for the rest of the way. So we got to do it. We need some energy for this. We're going to crush that bad boy real quick and then we're going to hightail it up there. Look at this. This is what we worked for the whole time. There she is. This is the crater rim. And that is the summit of Mount St. Helens. If this were 1978, we would need to go another 1,312 feet. Looking north, you can see the blast zone. That blast zone on May 18th, 1980, everything 6 miles northwest of this volcano was absolutely obliterated. It was crushed, destroyed, obliterated. Geologists said it looked like the surface of the moon. Everything 6 to 13 miles out, all the vegetation died. Trees were left standing dead, vegetation was killed. It was just an absolute, it was like the surface of the moon. It was an absolute wasteland. The eruption had the lateral blast, the pyroclastic flow, the landslide that took everything out over there. Looking south, we see that we still have old growth forest. We have old growth forest, a lot of greenery, and we have the preserved Fuji-like cone of Mount St Helens, at least the backside of it, missing the summit. Looking straight down right there, we can see the lava dome. That lava dome was not there when Mount St Helens first erupted in 1980. When it erupted in 1980, there was a hollow crater right here, and the vent was all the way at the floor of that crater. But from 1980 to 1986, and again from 2004 to 2008, this volcano effusively erupted dacite lava. Basically, thick lava like toothpaste was seeping out of the crater, coming up, cooling, collapsing on itself, and forming this mound. It's actually part of how stratovolcanoes rebuild themselves. So the lava came up, cooled, and sloped down to basically form that lava dome. And given the rate of the 2004 to 2008 eruption, Mount St Helens could have fully rebuilt itself within 200 years. There were 17 pyroclastic flows that barreled down the mountain. Picture an avalanche of hot gas, rock, ash, traveling at speeds of 60 miles an hour up to 800 degrees Fahrenheit, traveling down the mountain, instantly melting all this snow, which created lahars. Those lahars are mud flows. Picture wet concrete barreling down a river valley, flooding everything, taking out bridges, taking out houses, taking out roadways, and it even made it all the way to the Columbia River between Oregon and Washington, and it actually lowered the depth of the river from 40 feet to 14 feet, and it choked maritime shipping for about a week. So here on Mount St Helens, the south side of this mountain is a story of biography. It's a story of old lava flows, the remnant Fuji-like cone of what once was before the 1980 eruption, and then we have the autopsy of what happened on that fateful day, or what happened on May 18th, 1980, when that giant eruption happened, devastating everything north of the volcano. Okay guys, that's it. That was a geology hike to the summit crater of Mount St Helens. Hope you enjoyed. Please leave any comments, any critiques. I'm new to editing. I don't even have a microphone, so let me know how it went. Also, I am fascinated by stories of the 1980 eruption. So if you were a witness to that, or if you have any stories, drop it down. I will read all of them. My dad witnessed it in 1980, and this was the volcano that made me fall in love with geology and volcanoes when I was like 7 years old. And now I study geology. So fascinated by that stuff. Drop that down. Thank you for watching. Enjoy.